Okay, today we will talk about linear equations. We'll talk about how to solve them, first with addition property. Addition property means if you add the same number both sides, the value itself doesn't change. Okay? First, we get back up. We have to identify what means linear equation. Linear equation means linear equation. Here we have so now we have ax plus b equals c. A, b, and c are numbers. A is the coefficient for that term, variable term. So we have also b and c. B the constant term, and c will be the answer. Okay? So now, first we identify what it means linear equations, what they look like, what they don't look like. We have here 1, 2, and 3 are all linear equations. Now, so we have negative 3x plus 14. X equals 21. 3 times x minus 1. And one variable, and all the variables have from the first power, meaning their exponents 1. We don't write power 1 because it's the same number. So 4 raised to 1 means 4. So to save time and effort, we don't write that 1. But having the power, the first power for each variable is important. Other examples, not nonlinear. One and 2, obviously you can see it squared and cubed. That, not the first power. Therefore, non-linear. Number 3 is 1x. The x, it's like a negative power. You can't have x in the denominator for linear equations. Now here, number 4, have those bars. What's that mean? That absolute value. Absolute value also not linear. You keep saying the word again and again, linear, meaning it's a straight line if we graph that. So these are non-linear equations. Now we're going to solve two equations and check both the answers. Most of you, most people, can see x minus 6 equals negative 9 and sort of feel like, I know what the answer might be. But the point right now is showing the process, okay? So here we have x with minus 6. The goal is to have x, or the variable, alone on one part of the equation. You may think about, what does it mean one side? All equations, if they have an equal there, have a left part and right side. So here, okay? Now, the property also, I can add things, add here, but they have to match. Think of it like a teeter-totter, okay? If I add something here, I have to go over here and do it, or else it's not balanced anymore, okay? So if I have x, I want x alone. Means I want x plus 0. How negative 6 becomes 0? Think inverse. What's the opposite? Plus 6. But I had to both sides. So now we can see x plus 0, really for 0 plus or minus. 0 itself is not negative, it's not positive. So for simplicity, we'll say x plus 0 equals negative 3. Well, that means x equals negative 3. And that's a solution. Or we think it's a solution. Looks right, but we still have to check. How do we check? That number answer, negative 3, replace into the original equation. So now, here is my check. Notice I didn't solve for x. I didn't find x equals negative 9. The answer itself is not negative 9. This is just proof that my solution, negative 3, put in, gives me a true statement. Remember, equations equal, it's like a test. Left and right, are they equal? If I substitute negative 3, they will be equal. So, this is a solution. There's a lot there with that. Check equal negative 9 equals negative 9. True. Means x equal negative 3. My solution works. Okay? The next problem we'll solve right now. Talk about that. Please. Thank you. I forgot about that. I just dropped it and all of a sudden it... Okay, now we'll work on the other problem. Now, over here with b, we can see x plus 7. Again, think to myself, plus 7, I prefer 0 plus x. How 7 becomes 0? Take away 7. Anyway, you can see now negative 12 equals x. Again, we would replace x with negative 12 and show that negative 5 will equal negative 5. Also, we haven't fixed it now, but 7 subtract 7, 5 subtract 7, fine. Negative 5, negative 7. Later, you have a variable different places, remember you have to only combine like terms. Okay? So for now, that's enough for this video. So we had two 1-2 step solutions.